Today we're looking at trig properties part 2. So the first thing it's asking us to do is find the remaining trig functions if sine of theta is equal to square root 5 over 5 and cosine theta is 2 square root of 5 over 5. So we already have sine and cosine, right? We know tangent is the y over the x, or the sine over cosine. So let's go ahead and find that. So sine over cosine. Remember, we can always take the complex fraction and multiply by the reciprocal of our denominator. So the reciprocal of our denominator would be 5 over 2 square root 5. Now a whole bunch of things are going to cancel out. So square root of 5's cancel out, 5 cancel out. So then we have 2 in the denominator. And because everything in the numerator canceled out, we can't just put a 0 in there or leave it blank. We'll put a 1, right? So that's the tangent. Now let's do the reciprocals, right? So cosecant theta is the reciprocal of our sine. And we've already talked about this before, but we're going to try to rationalize now if we can. So all we have to do is take our square root in our denominator, multiply it by top and bottom. Square root of 5 times square root of 5 is square root of 25, which is just 5. And on the top we have 5 radical 5. And our 5's cancel. So this whole thing is just going to be square root of 5. So we have our tangent, we have our cosecant, we have our sine, we have our cosine. Now let's do our secant. Our secant is the reciprocal of the cosine. We're going to do the same thing to rationalize. We're just multiplying by that square root of 5 though. The 2 is fine. Now in the denominator, let's just write it like this here. 2 times square root 5 times square root of 5 is square root 25. Just like in the part before. So that's going to be 5. All these things cancel. So we have square root 5 over 2. And then cotangent is the reciprocal of tangent. And that's going to be equal to 2. So kind of similar to what you guys were doing earlier on. They're just throwing in some square roots and stuff. As long as you can rationalize, then you should be alright. Okay, example 2 is asking us find an exact value given one value and sine of another. So they're saying that the sine is 1/3 and the cosine is less than 0. So what we have to do here, remember cosine is x, sine is y. We have to figure out what quadrant our triangle would be in. So sine is our y. Y is positive in either quadrant 1 or quadrant 2. Right, so already we know that we're not looking at quadrant 3 and 4 because sine would be negative. And in this case, our sine is positive. Now of these two, where is the cosine less than 0? So what this is saying is cosine is negative because it's less than 0. So cosine would be positive in the first quadrant, but negative in the second quadrant. So we know that we're looking in quadrant 2. We don't know exactly what our triangle looks like, but we know it's in this orientation. All right, and what we know about sine now, because we're given sine is 1/3, sine is opposite over hypotenuse. So the opposite side is 1, and the hypotenuse is 3, because we know that our sine is 1/3. So what we're going to do from here then is we're going to find the values of the other 4 trig functions. So we have sine, we have cosine, we still need to find tangent, cosecant, secant, and cotangent. All right, so first thing we want to do here is we want to complete the triangle. And in order to do that, we're going to use our Pythagorean theorem. Make sure that when we do so, we're putting the hypotenuse as our c. So in our case, we have hypotenuse 3. And then we're going to solve. And then when we take the square root, we can simplify this. So square root of 8, some of us do the factor tree. Some of us can separate it into 2 different square roots. So square root of 4 is 2. And then we have that square root 2 left over. Make sure that our sign is correct. So notice that our bottom part of our triangle is 2 square root of 2, but that's also on the negative side of our x-axis. So we have to make it a negative. So make sure your signs are appropriate for your quadrant. Now let's go ahead and put this all together. Okay, so cosine is our x. We just found our x. So negative 2 radical 2. Tangent is going to be our opposite over our adjacent, or our y over our x. Keep in mind that we should probably rationalize, right? So this is going to be 2 times 2 is 4. So we have square root of 2 on top. And then on the bottom we have 4. And then we're going to do all of our reciprocals. So we have cosecant, which is the reciprocal of our sine. So that's going to be 3. We have the secant, which is the reciprocal of our cosine. Oops, sorry, I messed up the tangent. Let's go back to tangent. It's actually 1/3. So that we would end up with, sorry about that. Let's redo this tangent. 1/3 over negative 2 square root of 2, which we can multiply by the reciprocal of the bottom. We'd still rationalize, but this time we'd have our 2 times 2 is 4 times 3 is 12. And the top is still negative radical 2. The secant is going to be the reciprocal of our cosine. We're going to rationalize this. Square root 2 times square root of 2 is square root of 4, which is 2. And then 2 times 2 is 4. And lastly, do we have any room left here? Cotangent theta is the reciprocal of tangent. We can take it from any point. Let's take it from here. Which you have to rationalize. So then we have square root of 2, square root of 2 is 2. So this whole thing, 12 divided by 2 is 6. Okay, so there's a lot of rationalizing and algebra type stuff when we're simplifying these complex fractions, but the more we do, the better we get at it. All right, so let's look at one more. This time it's telling us that we have tangent 1/2 and sine is less than 0. All right, so let's go ahead and figure out which quadrant we're at. So tangent could be positive in quadrant 1 because the x and y are positive, right? Tangent is y over x. It also can be positive in quadrant 3 because if both the x and y are negative, then y divided by x becomes positive. All right, of these two, sine is less than 0, meaning negative, only in quadrant 3. So we're not in quadrant 1, we're not in quadrant 2, we're not in quadrant 4, we're in quadrant 3. Our triangle is in this orientation here. And the tangent is the opposite over the adjacent. So the opposite side of our angle is going to be 1. And our adjacent side is going to be 2. All right, so again, we're going to go ahead and complete the triangle. So this time we're given both legs. We're trying to find the hypotenuse. So we have 1 plus 4, which is 5. And we square root, so we know that C is the square root of 5. That's our hypotenuse. All right, so let's go ahead and figure the rest of this stuff out. So we know the tangent is 1/2. We can find our sine, so our sine is going to be the opposite over the hypotenuse in this case, right? Be very careful. Note that we're not using our unit circle, so we can't assume that our hypotenuse is 1. Our hypotenuse is square root of 5. So it's 1 over radical 5, which we need to rationalize. 1 times square root of 5 is square root of 5. Square root of 5 times square root of 5 is square root of 25, which is just 5. Okay, so that's our sine. We know our tangent. Let's do the same thing for cosine. So cosine is the opposite, the adjacent over the hypotenuse. Adjacent side is 2. We're going to rationalize again, times by square root of 5. So numerator is 2 radical 5. Denominator is radical 5 times radical 5, which is radical 25. Square root of 25 is just 5. All right? Now let's do our reciprocals. Reciprocal of tangent is cotangent. Reciprocal of sine is cosecant. And reciprocal of cosine is secant. Okay, so the cotangent is easy. Reciprocal of 1/2 is 2. Now let me show you a little trick here for cosecant and secant. We can take this at any point. So if we did the final answer here that's reciprocated and did the reciprocal of that, we'd have to reciprocate again, and it's going to be more work. However, if we take this thing that we started off with, right, before we rationalized and flipped it over, then that's just going to be square root of 5. And then same thing with the secant. If we take the cosine at this point and reciprocate it, then we just have to do square root of 5 over 2. Right, so you could use these final ones, but we just have to reciprocate again and it'll make our lives harder. If we can reciprocate from another point in our calculations, then you should be good. All right, that's it. So just some practice. It's not widely used outside of trigonometry, but it is something that they do like to ask on standardized tests. So you probably will see stuff like this on SATs or ACTs or college type exams. So just be aware of how to do them and you should be okay. So make sure you have your notes taken down, write down any questions that you have, and we can talk about them next class. All right, see you next time.